So hello, everyone. Let me start with a little story. So a few days ago, I was at my friend's house, and he made the most amazing cookies. So I obviously asked for the recipe and went home and started making the cookies myself. And I swear I'm a really good cook, but when I tasted the cookies after they were ready, they were really bad. Something was off. And now I was puzzled because I was trying to understand what exactly happened. So it could have been two things. It could have been maybe the recipe, maybe my friend here made a little mistake, and it's nice to blame other people. And it could have been the ingredients. Maybe they're bad, maybe I bought the wrong ingredients. I don't know. But when it comes to Flink, it's pretty easy, right? I can just go ahead, call my friend, and in max 5 minutes, we can understand exactly what happened. But when it comes, when it comes to Flink, when it comes to Flink, it's a little bit more complicated. So who here has experienced this? You run your Flink jobs, and then suddenly you get this really off result, and now you need to go back and trace to understand what happened. So please raise your hand if this really happened to you. OK, good to know. So hello, everyone. I'm Shai. I'm a product manager at Datorios.
Hi, my name is Colton Pilgreen. I'm the resident Flink expert here at Datorios.
And today we're going to talk about a real-time policy engine and how we fixed it using Lineage. And more specifically, we're going to show you how Lineage can help you manage your Flink jobs in a much more safe, solve problems faster, and most importantly, avoid very costly mistakes. So back to the cookie analogy. And now imagine you're not just baking some cookies at home like I did, but you're running this huge cookie factory that's baking thousands of different cookies every single second. And if one batch goes bad, pinpointing the exact moment where the process went wrong can be really difficult, because it could have been the process, the ingredients, the timing. It really could be anything. And like we already said, when it comes to Flink, the complexity increases much more, where you have tons amounts of data flowing at super high rate with so many moving parts. Any problem can arise, and it can be anywhere inside your pipeline. So the complexity stems from three main factors: the speed, the volume, and also the amount of transformations and operators your data goes through. So without the right visibility inside your pipeline, tracing what happened can be almost impossible or can take a lot of time. So we need some kind of tool that can help us understand the data flows, to really understand what happened, when it happened, and why it happened. And that's the real power of data lineage when it comes to real-time data processing. And you now might be asking yourself, what is data lineage? So data lineage is the ability to understand the transformations and movements of a single record throughout the pipeline. It gives you the full story of what happened to every single piece of data in your Flink job, to provide transparency and accountability to all your data movements and modifications within your job. And when it comes to real-time data processing, it's even more important and more challenging, because as we all know, things happen really fast. So we need a tool that can help us understand fully the entire picture, to understand and answer questions like, where did this data come from? What transformations did it go through? Why did I get this result? And most importantly, how exactly? So you can go ahead and fix it right away. And now you might be asking yourself, wait, I thought we already had tools for this. So the answer is kind of, because it gives us almost the full picture. So let's look at Flink, the Flink job graph, for example. It does give us a high-level view of what could have been happening inside our job, but it doesn't give us the ability to really peek and look inside our data. And in situations like the one we're going to talk about today, you need a much deeper, granular understanding into what is truly happening within your Flink jobs. So I think now is a perfect timing for our use case. So Colton, can you please take it away?
Yeah, so today we're going to be talking about the compliance engine. So Local Corp has enlisted their crack team of data engineers to make sure their fellow coworkers are following local traffic law and environmental regulations. They've received an upspike in calls that their field workers have been, speeding and idling in places that they shouldn't be. So local corp has tasked the data engineers to come up with a way to report on these unwanted behaviors. The good thing about this is they already actually had a telemetry stream laying around, so turning these into vehicle events wasn't that hard. And creating policy violations on these is a pretty easy process, so it was actually a perfect use case for Flink. So on to vehicle events. So this is the first start of our journey and also our field workers' journey. Every morning before a field worker goes out into the field, they have to open up local corp's app and select the vehicle they're taking out for the day. Once ever they've done that and they're actually started on their route, every once in a while the phone's going to send back some telemetry data to the telemetry data API. These telemetry events are then used to calculate the speed and the idle status of the vehicle, and also enrich which zones the vehicle's in. The API then constructs the new vehicle event with all this information and then places it inside of Kafka. The telemetry API also places its raw telemetry events inside of a different Kafka stream so they can be written by another Flink pipeline to an iceberg table. Now, drum roll, please, for the star of our show, policy. That's probably something you'd never thought you would hear about policy, that it's a star of a show. So our policies here are a collection of rules which are defined by our lovely compliance team. These policies have one of two types, time or speed. We use the speed policies to track if someone's driving too fast or too slow inside of a zone. And then we use time policies to track if, they've been idling in a place for too long. These policies also have a profile, so, maybe you don't want to, if you have a diesel vehicle, you don't want it to have a speed as high as, a regular car, or maybe you don't want to enforce idling violations on electric vehicles. These policies and their rules are actually stored inside of a MySQL database, and then we use Flink CDC to capture all of the changes, the modifications, and deletions of these policies. So here we have, an overview of our job graph. On the left, we have our policies and vehicle events. In the middle, we have our event policy matcher. This takes the policies and checks the profiles against the incoming vehicle events to make sure they match. And on the right, we have our session windows. These, combined with some custom window triggers, are used to compute policy violations. OK, so what was the problem with this pipeline? Kind of felt like Schrodinger's cat, but for vehicles. The pipeline was turned on. We began collecting the policy violations. And the good news is the first compliance report came out, and it had 73% in compliance. That's pretty good, pretty good win.
Pretty good.
Yeah, and it's kind of a huge win for local court because before, they didn't even know who was violating or even if they were violating. But there was one employee who said that he wasn't in compliance, but our report said he did. He was adamant that he was not speeding, and the report was unjustly blaming him. So do we think it was a bad actor, or do we think the data team's to blame? What do you think, Shai?
I think it's your fault.
It normally is. OK, so what was the root cause? Who was to blame? In the end, it was actually a troublesome system design. Isn't it always? So, the problem here is the system design lays in how we tie vehicles to a user. Vehicle telemetry is used to form together vehicle events. But, so as I said, every morning before a driver goes out, they have to select which vehicle they're taking. There's actually no locks or controls, to prevent two different drivers from selecting the same vehicle. So when the app sends vehicle telemetry back to the API, two vehicles could, be reported as one, and that's bad. This essentially made our compliance engine think the vehicle was pinging back and forth all throughout, the area. In reality, this driver was actually being wrongly blamed for violations that weren't even real in the first place. And also, the reports generated by the BI team, they were inaccurate due to a bad join. So since vehicle telemetry and events have no ties to a user ID, neither do our violations. So the BI's join was using the driver vehicle table, and it was grouping together the max state and vehicle ID, and then it was selecting max driver ID. Not good for us. But the good news here is it actually wasn't the data team that's to blame. We actually get to blame the architects and even the API team.
Yay.
So what goes into an investigation of a Flink pipeline? How do we debug a real-time, stateful application? The answer is time and headaches. So the first part of the investigation is simply gathering the data. And this can actually feel like playing a game of whack-a-mole, especially if your system's designed to keep data in several different places like this one is. The first issue is, so we use Kafka to store those vehicle events, but they're actually not stored anywhere else. And when we started this investigation, it had passed the Kafka topic 7-day retention policy. This means we actually have to go grab all of those vehicle telemetry and reprocess them. And while those are being reprocessed, we can actually go pull our policies from the MySQL database. Now that after we have all those, we can repopulate our new Kafka topics we're going to reprocess from. And now, reprocessing the violation, thankfully, because we're using Flink, that's pretty easy. You just have to adjust some configs and update which Kafka topics you're going to be consuming from. And then after you use this, you can submit your job in batch mode. And then you can go and use a tool like KCat to go and pull all those new violations out of our new Kafka topics. The good news is, after we did all this, the violations were the same. But the bad news is it actually doesn't tell us that this was a problem. It just tells us that we didn't lose any data along the way. So, well, now it's time to go look at our source data for the pipeline. So we can go back to Kafka, use KCat, look at our source vehicle events, and see what's wrong. And when we did this, we actually saw speeds that were topping at around 36,000 kilometers an hour, which is impressive, but it's not something that's even realistic. And if the driver was able to achieve this in Los Angeles, I want to have a different conversation with them. So what's the problem? It seems like the API team must be sending us bad data. So we're going to actually punt this investigation back to them. But how can we run this investigation with a better tool?
OK, so thank you, Colton. And now we're going to do a short demo to see how we can actually do this whole headache in the Datorios Lineage tool. So the first thing I'll do is I'll select a job, and it's the job we're talking about. And the first thing we need to do is to select the sink we'll want to focus on. And I'll select the upper sink because that's the one for the speed violations. So after I selected the sink, I'm presented with all the records that ended up at that point. And now is a very important step in our investigation because we need to go ahead and select the record we'd like to view lineage for. So we added a filter bar to make the step easier. And what I need to do is just insert the vehicle ID of the driver, the vehicle the driver was using the other day. So I'll just go ahead, insert that into the filter bar. And then we have all the records associated with our driver. So now I'll just select one of them because they're all violations our driver made, our poor driver. I can verify this is the record I want to focus on because I can see the data in a more easier view. And I'll click on View Lineage. So now I can see the lineage for this data, the upstream lineage, up to we hit a window. And we can see we had 413 records that entered the session window that created our policy violation. And we have those number buttons, and we can actually click on them to see the data and inspect the data deeper. So let's go ahead and click on that 413 button. And now we can actually go ahead and view all those records that entered our session window to create that specific violation. And now I would like to open up and inspect the data of that specific record. And what I want to do now is check if the rule was applied correctly. So we can see our rule. We see I need a number between 0 and 120, and we can see our speed. And in this case, I don't know if you can see, the speed is 14,000 kilometers per hour. So the rule is applied correctly, but this doesn't make any sense, right? So this is a not realistic speed. So now what I want to check, if this is our fault, maybe somewhere in the pipeline the speed was miscalculated, or maybe the records are sourced this way. So I can go ahead and check that right away. So I'll go ahead, select that specific record, and now I'm presented with the upstream lineage for that specific record in the window. And I would like to see how that specific record entered from the source. So what I can do now is just inspect and do a side-by-side comparison to just verify that the number is identical. So let's do that, and we can see it is. So once again, We know it's not our fault. We know we need to talk to the API team, update them that they're miscalculating something, and that's about it.
Yeah.
So let's take a few minutes to compare the two approaches, the one Colton demonstrated and the one I just did. And we'll use two critical operational metrics. So the most intuitive one is time. And we can see that it was 13 times faster to conduct this whole investigation using the Datorios Lineage tool. And this isn't just about speed and reducing, just like saving time for your team. This is about reducing potential downtime. The more time you waste on those investigations, the more risk your bottom line of your business will get hurt. And moving on to the second one, is the amount of tools needed. So we saw in Colton's demonstration that he was talking about jumping back and forth between 3 different tools. And this isn't just annoying and a waste of time. This can also be confusing, and that can lead to mistakes. And when it comes to your data integrity, these mistakes are not something you can afford. So having everything on one unified platform makes everything easier, but also way safer. So let's talk about the business impact of what we just learned. So a very important metric when it comes to real-time data processing is MTTR, which is mean time to resolution. And with a good, real lineage ability, you can reduce MTTR dramatically. And in high-risk industries such as finance or transportation, for example, having those kind of mistakes is something you just can't have because they can lead to customer dissatisfaction. But even worse, it can lead to penalties, regulatory fines. And that's something none of us wants, right? So that's very important. But the most important thing is not just preventing mistakes. It's actually what I said before. It's about the fact that you're reducing your risk of hurting your bottom line and of hurting your business revenue. So the longer your systems are down, the more expensive it becomes. And when you have a tool to help you, tackle those kinds of situations, you can just reduce that risk dramatically. So to sum up everything we've talked about in the last few minutes, having a real lineage ability is not just some kind of tool to help you solve technical problems. It's a real strategic investment. And if any of you are using Flink, and I'm sure you are, having this kind of visibility and control isn't just a luxury, it is a necessity. So thank you very much. And we weren't really making cookies, of course. So yeah, any questions? Yeah.
Thank you for the presentation. I would be interested in how you deal with the deserialization of the messages. So in this example, was it in JSON representation, or did you do some deserialization? And is it flexible? Is it something that we can extend?
So actually, it just uses the toString method of your objects that you're.
Okay.
Yeah. So we use Scala in the background. So it's a case class. Scala's toString method just basically takes the case class and then fills in the spots.
Okay. Okay. Thank you.
Thank you.
Thanks a lot for the talk. How does this perform at scale? Like, not talking about 100 of records coming in, but like millions, billions?
Yeah, so the Datorios telemetry collector actually works in the background and exports the data to an agent, and the agent does all the processing. So there's actually a very, very small performance cost.
So what benchmark have you run? Like how much?
I actually don't know what's the biggest job we've ran. But come and talk to me after the booth, and I'll let you know.
Come to our booth. We'll discuss that deeply.
Thanks.
Thank you.
Thanks for the presentation. It's really cool to have a visibility on the data. But I have a question regarding the security of the data. What if I process sensitive data? How do you manage the authentication or the security? I mean, for example, in this demo, this user can see everything, or, I mean, what is the granularity if you have any access management?
Yeah, so it depends on the deployment method, and we also support data masking. So if you want to deploy this inside of your own Kubernetes cluster, data's all yours. It never leaves your system. And then also, if there's also data masking. So if you want to mask data, sensitive values, you can do that, and you can apply rules to those.
Yeah, would work.
Yeah.
Thanks.
Thank you. So if you didn't enjoy our, there's a joke. OK, you saw the joke already. So thank you very much. Come visit us at our booth. And if you would want a more deep dive demo, we'd love to do that. Thank you very much.